You can see there is 1 carbon and 4 hydrogens. The carbon is located at the center, the 4 hydrogens around the perimeter, and each has 1 stick there that represents a single bond, which means that they're sharing 1 pair of electrons per individual stick there. And what's unique about how they are sharing these electrons in each one of those little sticks there is that they are equally sharing those electrons. So equal sharing of electrons is what we call a non-polar covalent bond, and we can see 4 of those non-polar covalent bonds there. Moving on to our next example, we have an example of oxygen gas, and this is composed of 2 oxygen molecules and a double bond between the two, meaning that they are sharing 2 pairs of electrons, and how they are sharing those electrons is equally. So we would call this a non-polar covalent bond. Moving to our next example, we can see this is a molecule of hydrogen gas. You've got 2 hydrogen molecules, or 2 hydrogen atoms there that are held together by a single bond. So it's a single pair of electrons that they are sharing there, and they're sharing those electrons equally. So we would call this a non-polar covalent bond. Okay, so here we've got our carbon dioxide molecule. It is a little bit larger than the ones we've seen before. It's our first example of a compound that we've seen, and that just means that it is a molecule that is composed of more than 1 type of element. So you've got carbons and you've got oxygens there. Technically, the methane that we saw as our demo molecule at the very beginning was also an example of a compound because it had carbons and hydrogens in it. So here there's carbon dioxide. We can see it's got the carbon and it's got the 2 oxygens on either side. We can see the sticks are representing shared pairs of electrons. And once again, what's unique about this carbon dioxide is that the oxygens are sharing those electrons equally with the carbon here. So equal sharing of electrons, we once again will refer to that as a non-polar covalent bond. Okay, the last couple of examples that we're going to see here, we've got a water molecule. And again, we've got 2 hydrogens and an oxygen that make up this molecule. You can see the oxygen at the top in white, and you can see the 2 blue hydrogen atoms there towards the bottom. And once again, the sticks are representing those shared pairs of electrons. So we've got 2 shared pairs of electrons, but what's different in this water molecule is that the hydrogen and the oxygen are not sharing those electrons equally. In fact, those electrons are spending most of their time near the oxygen and very little time at all near the hydrogens. And so that results in what we were calling a polar covalent bond. So since those electrons are going to be spending most of their time near this oxygen, we can draw this end of the molecule with a slight negative charge. And because those electrons are going to spend very little time near these bare protons down here, those protons are just giving off their positive charge. So these water molecules are like little magnets where one end of them, the oxygen end, is going to be negatively charged, and the other end, the hydrogens, are going to be positively charged. So moving on with our last example here, we have built a molecule of ammonia. And here we've got a middle nitrogen represented in green here, and it has formed 3 of these single bonds with hydrogens. We've got 3 hydrogens there. Each one has a stick representing that shared pair of electrons. And once again, we are not going to see equal sharing of electrons. Instead, those electrons are going to spend most of their time near the nitrogen. So we can once again kind of consider this end of the molecule slightly negatively charged, and these protons down here, these individual hydrogens, are going to be pretty much just that bare proton with the positive charge. All of their electrons are going to spend their time up here next to this nitrogen. So overall, this ammonia molecule is what we would also consider a polar molecule. It's like a tiny little magnet where it has poles on it, a positive end and a negative end. So once again, each of those sticks now represent our example of a polar covalent bond, unequal sharing of electrons.